Friends, welcome back to my channel. Now, after uploading two videos on sympathomimetics, still we have something to say about sympathomimetics. In my last two videos, basically I dealt on these things like the SAR of sympathomimetics. That means the making of sympathomimetics. That means what are the features that should be incorporated in a particular chemical entity so that it can be well accepted as a sympathomimetics, right? It can work on sympathetic system and thereby it can be considered as a sympathomimetics, right? So there we found, yes, there are three essential features which should be incorporated. A hydroxylated phenyl ring, to that phenyl ring an alkyl chain should be attached, right? And we have seen there is a restriction in the number of number of carbons, right? Okay, which constitute the alkyl chain, right? That should be of 2, right? And that is why sometimes they are also calling it as aryl ethanol amine, right? The other name of this catecholamines, because there are so many names, okay, so many names for this sympathomimetics. Sometimes they are calling it as sympathomimetics, sometimes they are calling it as adrenergic agonist, sometimes they are calling it as chemically, right? Ethanol amine, right? Or ethanol amine, no? That means aryl ethanol amine. It's not simply ethanol amine, right? Aryl ethanol amine, right? Sometimes they are also calling it as beta aryl alkyl amine, right? So like that. So it can be named, it can be considered, or it can be given so many names and all, right? Okay. Some are based on pharmacological, features. Some are based on chemical features and all, right? So anyway, from our last understanding, we came to know that what are the things like your aryl ring system. To this one alkyl chain, and then to that alkyl chain a terminally placed amino should be there, right? And to that amino, right, further alkylation is possible, right? And if a bigger alkyl is there, like tertiary butyl, there we found that beta 2 selectivity increases, right? Okay, whereas for this unsubstituted one, I'm talking about primary one, because there are two options that are given to you. That is, one is your primary or the other one is your secondary, right? But we have seen that the one which is found to be unsubstituted one, I'm talking about the amine, right? So in that case, I think there is no such kind of beta selectivity you can find, right? Whereas it is non-selective one, right? Yes, it do have some affinity, it do have equal affinity towards alpha as well as beta, but we cannot say that it simply so goes to or plummeted towards beta receptor, right? But the moment we brought like alkyl, then isopropyl, and then tertiary butyl, suddenly we found that yes, there is extreme selectivity towards beta 2 receptor, and that is why most of the beta 2 agonists which are given in bronchospasm or COPD, right, which are used, right? I should not say COPD can only be treated with beta 2 agonists, right? There are several drugs which are given, which has to be given, okay, which has to be incorporated in the regimen, right? But for this asthma, okay, yes, we have a beta 2 agonist, and along with that a particular steroid, right? Mostly the glucocorticoids, they are being used, right? Like fluticasone and all these things are there, right? So anyway, so these are the things, and we have seen that in my last video also. We have seen that how these features, how this concept, okay, concept was materialized in order to generate so many sympathomimetics, right? Okay, there we found, we talked about, and basically the thing is that we talked about, on the basis of our SAR study and all, we dealt with few drugs, like starting from norepinephrine to epinephrine, then salbutamol, right? We have seen that how the IPC name can be generated, okay, from the structure, right? And what are the tricks that should be adapted, what are the tricks that should be opted, okay, in the process of developing a structure, okay, from the name itself, from the common name itself, right? Okay, so now let us move on, right? Let us move on to few more drugs, right? Few more drugs. We'll see their nomenclature, if possible, the clinical category as well, and then we'll move to few synthesis as well, right? The synthesis which are kept in especially the BPharm syllabus, right? Okay. So let's move on, right? So today let us just bring another one, right? We are done with a non-selective sympathomimetics. We are done with beta 2 selective, right? Beta 2 selective sympathomimetics, right? Okay, but we have not seen alpha 2 agonist, right? Alpha 2 agonist. Let us just bring one alpha 2 agonist, right? I'll give at least one example for each and every pharmacological category, right? We have basically non-selective, then we have alpha 2 agonist, then we have beta 2 agonist. Actually, these are found to be mostly dominant, right? Okay, mostly found rather. Okay, yes, we do have some alpha 1 as well as beta 1, right? But we are not talking about that one. Why? Because they are found to be mostly untouched, right? Okay, so now let us see that the alpha 2 agonist, right? Okay, now alpha 2 agonist, alpha 2 adrenergic agonist, right? Okay, alpha 2 agonist, alpha 2 receptor. We know that exactly it is where exactly it is located. It is the alpha 2 receptor that is located presynaptically, right? So we have something like this. Assume that this is found to be the nerve ending, right? So it is the alpha 2 receptor that is located somewhere here, right? And this is found to be the synaptic cleft. And we have postsynaptically placed receptor like your, say, anything like beta receptor. Then we have alpha 1 as well, right? Okay. So what is the function of autoreceptor that I told you, right, long back? Well, because if there is an excess release of norepinephrine under the influence of that particular impulse, right, which is carried all along the axon, coming here, pushing the storage vesicles towards this terminal membrane, right, when there is a proper fusion that is being taking place, and then there is the exocytosis, and which eventually leads to the release of what? The neurotransmitter. Where? Here, right? So that they can efficiently and effectively bind to their corresponding or respective receptor subtypes, and finally execute or emerge or develops the biological response, right? Chalo. So autoreceptor, that means if this particular autoreceptor, the functioning of autoreceptor can be exploited, okay, in dealing with hypertensive crisis. So that is why alpha 2 agonist, basically alpha 2 agonist, they're mostly used in the treatment of hypertension. Why? Because in hypertension, actually, there is an excess release of norepinephrine, right? As a result of it, that means when there is excess release of pressure amines, what will happen? Definitely, the subject will feel, in a hypertensive. The subject is suffering from hypertensive crisis, right? So by just with the help of this autoreceptor stimulation, what can be done? The excess release can be controlled, because the purpose of autoreceptor, or the function that is being served by autoreceptor, is whatever excess amount that is being taken up by the autoreceptor, so that it can nullify the hyper effect of what? The biogenic amines, right? Chalo. So that means autoreceptor. So alpha 2 receptor being placed presynaptically can serve as an autoreceptor. So what exactly we are after? Stimulating the receptor, not inhibiting the receptor, because here the clinical condition is hypertension. And how it is, how hypertension develops? It is out of excess release of biogenic amines, right, or pressure amines, right? So we need to control the release of amines, right? And thereby we need to stimulate the alpha 2 receptor, right? Chalo. So alpha 2 receptor, we have ample number of examples here, but in your syllabus, okay, we are done with, I think, these things like alpha methyl dopa, right? Alpha methyl dopa is another example of a centrally acting, alpha 2 agonist, can be given to the patient who is suffering from, hypertension, right? Okay. So that was of, the modification which can be brought in the general template of sympathomimetics, right? That is beta aryl alkyl amine, right? But we have additional template, right? That is also been given to those to a particular drug, okay, which can effectively, yes, for the last 20 to 25 years, right? This particular category of drug, okay, they are serving the mankind, right? Okay, so we have a drug called clonidine, right? Clonidine. So clonidine is an example of, alpha 2 agonist. But let me tell you one thing: clonidine is not at all, I should say, complying or obeying the classical feature of sympathomimetics. That means beta aryl alkyl amine, right? Okay. Let us just see that how the structure looks, right? Clonidine. So as I told you that yes, first thing is that just focus your attention to the name itself, right? Deal with the name for at least 1 to 2 minutes, right? So that you can at least, whether it has something to say to the viewer, right? Okay, let's see. So if we just try to focus on this particular thing, right? It says the word clo, that means chlorine, right? Idine means what? Idine means, we know about pyrrole, we know about pyrroline, we know about pyrrolidine. Same thing we know about, that means I'm talking about five-membered heterozygous, right? 5-membered heterocycle. If we keep on removing the pi bonds, the moment we'll just remove one pi bond, this will become pyrroline, and by removing both the pi bonds, that has become transformed into pyrrolidine, right? So same thing happens to imidazoline as well. So lidine means, it says about what? It says about 5-membered heterocycles. So these are the two informations that can be extracted from the name itself. What are those? The thing is that we have a chloro, there may be a chloro, okay, at the same time there may be a heterocycle, right? So like that, so likewise, let us just proceed and let's see that whether we can we shape the drug in which these two entities are there, right? Okay, let's see how it goes actually. So now clonidine, actually clonidine is a cyclic guanidine, right? The chemical category that can be given, or the chemical, the chemical classification that can be given to that particular clonidine is an example of closed guanidine, right? So guanidine is what? Not guanine. Guanine is an example of purine. Guanidine is nothing but it's having a close resemblance with the structure of urea, right? Urea is what? Urea is H2N C double bond O NH2, right? Okay. Suppose if I just remove the sulfur over here, if I just remove the oxygen and just putting sulfur over here, so it has become what? Thiourea. Now assume that the sulfur has been replaced with an NH. Now it has become guanidine. So as I told you, this is found to be the open form of guanidine, right? So we have a chemical category lies in oral hypoglycemic called biguanides. We have an example. We can metformin, fenformin, all are examples of this biguanides. Here only monoguanidine is there, right? If we just merge another guanidine, right, then it will become biguanides, right? I'll not go to that. So let us just see that if we just try to cyclize it, okay, yes, at least a portion can be cyclized, but you have to set free a particular portion. Let us see. So if we just try to draw this one, like this, right? Nitrogen, nitrogen, carbon, nitrogen, 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 carbon, nitrogen. Having a resemblance, right? Having a similarity with that of the open form, right? So it's a closed form, right? We have guana bench, we have guana casein. They are found to be the example of this, open guanidine. But this is clonidine is an example of, a closed guanidine, right? So with that we can say yes, it is having or it possesses guanidine, but in a different way or different form, right? Okay, chalo. So that means guanidine is there. So we are done with at least one of the thing. That is, एक तो गुआनिडीन हमको जानने में आना, दूसरा क्या है? दूसरा अभी जो बोले क्लोनिडीन में क्या था? एक क्लोरीन था, एक नहीं मतलब क्लोरीन था, और क्या था? एक 5-membered हेटेरोसाइकिल, ठीक ना? इडिन, राइट? अब देखो ये तो इडिन नहीं है. The moment we are just removing this one, okay, this can be removed, okay? But what will happen to this? Then this will get converted to double bond, right? The same thing, no? So that means yes, it possesses something like this, and in which say this is the another form, or we can say this is a tautomeric conversion is all the time going on in between this and that, right? This and that, okay? So at least a tautomer is existing, or tautomerization is possible here, right? Chalo. So now let us deal with this particular form in which guanidine, that means imidazole, is in the form of imidazoline. But if we just stick to imidazole, we need to mention the hydrogenated area along with the hydrogen, right? The way by which, say for example, if we are very stubborn in nature, if we are very stubborn, no, I should write imidazole over here, right? So in that case, you need to mention the hydrogenated area, right? So if we start numbering from here, 1, 2, 3, 4, 5. So it is the 4th and 5th position that is hydrogenated. So you need to mention in the IPC name that 4, 5 dihydro. We are left with another hydrogenated area. So that is why 1H, imidazole. This is imidazole. Now we can say imidazole, right? But if we are not say if by any means, okay, no, we don't want to mention the hydrogenated area. In that case, no longer you should put the term called imidazole there. It should be kept as imidazolin. Zolin. Why zolin? Because it still have a pi bond, right? It is supposed to have two pi bonds, and so that it can comply the Huckel's rule and all. Anyway, so now this is the fourth and fifth position which is found to be hydrogenated one, and one more thing is that it is the first position that possesses a hydrogen. So that is why you are supposed to write it like this: 1H, then 4, 5 dihydro. Right? Chalo. So now what are the other thing? So we are left with the chlorine, right? Yes, imidazole, clonidine, especially the clonidine type of compounds. Okay, they are having two chlorine, right? Which are placed 2 and 6 position. It is the second position and the sixth position that is holding what? 2 chloro group, right? So this is the basic form, or this is the final form of what? Clonidine. So as I said, that clonidine can be given to the patient who is suffering from hypertension, right? Hypertension. Okay, don't get confused, because we are done with the beta 2 agonist. Now we are in the process of we are in alpha 2 section, right? So alpha 2 is not meant for bronchial expansion or bronchial smooth muscle relaxation, right? So it is for what? It is for alpha 2, that means autoreceptor stimulation, right? Okay. So clonidine basically serve as an antihypertensive acting on alpha 2 receptor, and thereby thereby slowing down the release of norepinephrine, okay, which we are after. Actually we are after reducing, or we are after lowering the rate of release of norepinephrine that is found to be the pressure amines, right? Chalo. So this is about its clinical significance and all. Now coming to this IPC naming and all, okay, it's a simple thing. First and foremost, we are partially we are done with the IPC naming. So here we know that if we stick to imidazole, that you need to mention the hydrogenated area. Same thing has to be applied to any other heterocycles and all, whether it is nitrogenous or oxygenated or sulfonated. Okay, that is a different thing. But irrespective of their heteroatoms, if within the cycle, if within the within the cyclic system, if pi bonds are missing, okay, you are supposed to mention the hydrogenated points, right, in the IUPAC name. That is the way you should follow, right? Chalo. So this is 4,5 dihydro 1H imidazole. So we are left with what? Amine. So basically this is the portion that is nothing but amine. Now, so basically this is imidazole amine. Okay, we are done. And prior imidazole, you are supposed to put what? 4,5 dihydro 1H imidazole amine, right? Okay, so we are left with the substituents. So here the major substituent is there, and the substituent is being held by the NH. It is the NH that is holding what? That is holding the substituent. The substituent is what? The substituent is phenyl, and the phenyl is substituted phenyl. So that is why 2,6-dichlorophenyl. Okay, now one thing is that as it is an amine, you need to go after the nature of the amine. So here the amine is found to be secondary in nature. If amine is found to be secondary in nature, so that means the way it should be named is that you need to mention, instead of 1, 2 or any Arabic number and all, you have to put the alphabet as N. This is the thing that is applied to tertiary as well as secondary, not primary, right? Okay. So if the secondary as well as the tertiary amine is holding any substituent, in that case, the substituent has to be mentioned, but prior to that, the N has to be mentioned. So it is the N of this secondary nitrogen that is holding what? 2,6-dichlorophenyl. So that is why you are supposed to start up the process with N, then followed by 2,6-dichloro. So this is 2,6-dichlorophenyl, right? We are done with this. Next is what? Next is 4,5-dihydro 1H imidazole. Then amine, that's all, right? So this is the way the IPC name of clonidine, okay, can be generated or can be made, right? Okay, can be written rather. Now, okay, so we are done with this alpha 2 agonist, right? So till now we are done with the beta 2 agonist. Till now we are done with the alpha, beta, that means non-selective sympathomimetics. Now we have already covered this alpha 2 agonist. Now we'll see that the one which can act on both the things, like alpha as well as beta. I mean to say dual acting, right? I mean to say dual acting, right? So if we just pick a particular drug which is acting as a dual acting sympathomimetic. So we have a drug called dobutamine, right? Yes. Dobutamine, right? Okay. Dobutamine, basically it is given in during the heart failure and all, right? Okay. The subject who is susceptible towards heart failure can be given dobutamine, right? Okay. Because dobutamine can be clinically called as inotropic agent. Inotropic. Okay. It's an inotropic agent. Inotropic agent. It is acting. Inotropic agents are those, or we know about inotropic, we know about chronotropic, we know about dromotropic, right? So inotropic is nothing but the one which is acting on force of contraction of heart, right? That means the one, I mean, if I say positive inotropic effect, right? What does it mean? That means the effect which causes what? An increase in what? Increase in force of contraction. And if we see chronotropic effect deals with the rate. That means positive means the one which can enhance, which can increase the rate of, heart rate. Okay, heart rate, the one which can increase the heart rate can be called as chronotropic agent. The one which can act on force of contraction and just accelerate it, that can be called as inotropic agent, right? Okay, chalo. So that means, and let me tell you, during the when a patient is at the verge of heart failure and all, so prior to that, he or she can be given with dobutamine. Why? Because at least with the help of this dobutamine, out of this forceful contraction, probably the residual volume or the blood which is difficult to pump out, okay, can be ejected. Okay, can be ejected, right, out of forceful contraction. Okay, so dobutamine, as I said, this is an example of a drug which can act on both alpha as well as beta, right? Okay. Now the thing is that dobutamine, how is it possible for a drug to act on alpha as well as beta? Now let me tell you, it cannot act on alpha 2 receptor, alpha 1 and beta, both the beta, right? Okay, but dobutamine can show stereo selectivity. Okay, so that means stereoisomerism is there, or dobutamine can appear in the form of a pair of enantiomers, right? Pair of enantiomers, right? So that means, so as dobutamine can appear in the form of pair of enantiomers, so that means what we can say, and we know the effect of enantiomers in the process of developing pharmacological response, right? We have seen earlier that it is the stereochemistry. It is the stereochemistry that is having a huge impact in biology, in developing biological response, right? We have seen that a particular, if we are dealing with a particular pair of enantiomer, one form is found to be effective, the other form is found to be ineffective. One form may increase the activity, the other form may decrease the activity. So there is a deviation of activity, even though the elemental composition remains same, but still it is because of the difference in the spatial arrangement. The spatial arrangement, what happened? It loses a point of contact. I should not say a single point of contact, it may lose multiple point of contacts, and it depends. Biological, if the interaction is found to be formidable, then only we can expect a biological response. So that means the magnitude depends on what? The accessibility, whether it can access each and every point which is supposed to be met by the ligands or not, right? If any point is missed out in the process of dealing with the receptor active site or enzyme active site, substrate binding site, so there is a deviation of activity, and that is happening in case of so many drugs which can show stereoselectivity, which can show which is holding the element of stereochemistry in them, right? Okay, chalo. So now let us just deal with so this is all about your pharmacological aspect. I am not supposed to bring this kind of things, okay, in this discussion, because it is solely chemistry based, right? But it is for your interest, right? Okay. Now, so dobutamine is an inotropic agent. It's an inotropic agent, and by virtue of its inotropic effect, right? Okay, it can be given during the in heart failure, right? And moreover, it can be given yes, the particular clinical condition, that is CHF, right? It is basically meant for CHF, congestive heart failure, congestion. When there is a congestion, because of what? Congestion, the heart is unable to pump the blood out, okay? It is because of the weakening of the ventricular muscle, right? So that means some mean should be there which can at least stimulate what? The muscle tone, so that it can efficiently pump the blood out, right? Okay, and that the dobutamine is trying to do, right? Okay, chalo. So now let us deal with this, the structure and all. As I said, dobutamine can appear in multiple forms. Why? Because by virtue of its stereochemistry, right? Or by virtue of its stereochemical element, right? Okay. So dobutamine, as usual, we have to apply the tricks. So dobutamine, what should be there? As I said, alpha and beta, it is not violating the classical feature which should be kept in sympathomimetics. As earlier we have seen in case of clonidine, right? It has violated, at least mostly it has violated the classical requirement for the making of sympathomimetics. That means beta aryl alkylamine. I'm talking about that one only, right? Chalo. So dobutamine, do means what? Do means, if we just extend this do, it has become dopamine. Right? Amine is already there, and dopamine itself is having amine, right? Okay. So dopamine means dopamine. That means the drug may have dopamine-like structure in it. Got now? So now, additional butyl. Sometimes it is misleading, right? Why? Because buta, you may think, okay, chalo, buta means probably the secondary amine, okay, that is holding the substituent which may be a tertiary butyl. But the thing is that, and that is why I brought the clinical significance first. I told you, no, it cannot be given to the patient who is suffering from asthma. So that means forget about this beta 2 receptor. And when we got the beta 2 selectivity, the moment a bulkier substituent is placed at the terminal amine, preferentially tertiary butyl, then only we can get beta 2 selectivity. Right now. So in that case, what we can say that means here the buta. So whatever doubt that is likely to appear, that can be readily expelled, thrown out. Why? Because you have already dealt with the clinical significance. Right? So this buta should not be a tertiary butyl. Instead, this can be something like this: 1, 2, 3, and 4. It can be like this, or it can be like this. So these are the information that we have fetched from the name itself. Then what is left in the process? A few things which need to be remembered, right? Chalo. Let's see how this can be built. So dobutamine, we have seen that probably it may hold a dopamine like, may possess a dopamine in it. So dopamine means dihydroxy, so preferentially a catechol, right? So we have a catechol HO, then dopamine is not having any kind of beta hydroxy in it, right? Because it is found to be the immediate precursor of what? Immediate precursor of noradrenaline, right? Chalo. So now CH2, then okay, now NH, right? The NH should be a secondary, right? Or primary. It should not be tertiary. So that is why we have just put one hydrogen here, right? Okay. Now what next? The butyl, right? Butyl. So we are done with the butyl as well. So see, we can say CH2. I'm just satisfying the valency and all, right? But you are not supposed to write in this way, right? If you're just putting, if you're just presenting it in that form, I strongly suggest put it like this, right? So that it is found to be chemically correct. Same thing here also, right? Same thing here also. The best way to put like this, right? Okay, chalo. So now the thing is that after that what? So this is the extra thing that you need to remember. That is a phenol. A para-hydroxyphenyl is the additional thing that is there in dobutamine. Nothing is left in the process. We are done with the structure of dobutamine, right? So this is how dobutamine stands. Nothing is there. Dopamine. So this is found to be the dopamine. Okay. We are done with this dopamine. And then this is found to be the butyl. So we are left with only a single thing. That is para-hydroxyphenyl. Nothing is there. Right? Okay. Now let us see that how this can be named. And before that, let me just tell you that yes, as I told you that okay, it can appear in multiple forms, right? So what are those actually? So this is the area, right? This is the area where you can find the chiral center, right? So chiral center is there. That means it can appear in two different forms, right? Two different forms. So It is the one is found to be the positive, or D, the other one is negative, right? So what they found that it is the positive form of this dobutamine which grows affinity towards the beta receptor, preferentially beta 1 receptor. Why? Because I am telling that beta 1 receptor stimulation. It is the stimulation that causes what? Increase in force of contraction, right? Okay. And that is why we have just categorized it as a inotropic agent, positive inotropic agent, right? Okay, chalo. So positive, and it is the negative part that is developing an affinity towards alpha, preferentially alpha 1. Preferentially alpha 1, right? Okay, chalo. So now this is the thing. So as I said, we have a chiral center, and chiral center is there. That means it can appear in multiple forms, right? A pair of enantiomer, one is positive, the other one is negative. It is the positive that is towards beta receptor, and is the negative that is towards alpha 1 receptor, right? Chalo. So with the help of this two forms and all, that means the racemic forms and all, okay, it can deliver its efficacy and all, right? Okay, chalo. So now let us see that how the nomenclature can be done. Okay, how the nomenclature can be done. Let us see first. So nomenclature. So now nomenclature first. So this is the entire thing, right? So 2-hydroxy, no change in that. So we should go back to the norepinephrine part. There we have concluded, that time we concluded the event with the help of benzene 1,2-diol. So same thing here also we should opt. So that means instead of going in this direction, let us just consider this as the parent. The parent is benzene 1,2-diol. Right? Now it is the benzene that is at its fourth position holding what? The alkyl or ethyl. It is the ethyl at its second position holding what? An alkyl amino portion. Which alkyl amino portion? Butan 2-yl amino. Right? 1, 2, 3, 4. Butan 2-yl portion, right? It is the butyl at its fourth position holding what? 4-hydroxyphenyl. Right? So this is found to be the offspring of the entire thing. Right? Which is terminally placed and which has to be brought at the starting point, right? Okay, how? So likewise 4. So we have to start the process with 4. Okay, chalo. So 4 is holding what? 4 is holding ethyl. So 4 is holding ethyl, right? To that ethyl which is connected, the alkyl amine. Chalo. So to that ethyl, the alkyl amine is there. And the alkyl amino is being held by the second carbon. So that is why I have what I have written here, 2. So here you have to mention what? As I said, alkyl amino. Right? And it is the alkyl substituent at its fourth position holding what? 4-hydroxyphenyl. So likewise, it is the 4-hydroxyphenyl which is being held by the 4. Got my point? So it is the 4 within bracket, the fourth carbon holding what? The 4-hydroxyphenyl. Fourth carbon holding what? The 4-hydroxyphenyl. And the fourth is of what? Fourth is of this alkyl, then amine. So amino I have written here. And then we have to close the bracket. Then this one, the ethyl. Because this is found to be the primary substituent of what? Benzene, the parent. Benzene 1,2-diol. Got my point? So that is why. So 4. This is the 4. So here immediate next to this, at fourth position we have an ethyl. To that ethyl, at its second position, which is there, the ethyl. So that is why I have just kept it here. To ethyl. Okay? To that ethyl at its second position, which is holding what? The butyl amino. So the alkyl amino. So here alkyl amino is nothing but what? Butan 2-yl amino. or you can otherwise write like 2-butyl amino, right? Okay, chalo. So butane 2-yl amino. So butane 2-yl amino, right? And to this butyl at its fourth position, it is holding what? 4-hydroxyphenyl. So likewise, you have written 4. Immediate, see, once you are, you have put this third bracket, right? Immediate, next to this third bracket, you have to put 4. It is the fourth of what? Fourth carbon. Holding what? 4-hydroxyphenyl. So fourth carbon holding 4-hydroxyphenyl. Close the bracket then. 4 is a part of what? 4 is a part of butane 2-yl amino. 4 is a part of butane 2-yl amino, right? We are done with this. Then ethyl. And finally we are done. We are left with what? Benzene 1,2-diol. So this is the 4 of this, 4 of what? 4 of this benzene. So that is why 4. We are done with the substituent and then moving to the pairing, that is benzene 1,2-diol. Got my point? So this is the way the IUPAC name can be framed. Nothing is there, right? Okay. Now in my next video I'll come with the synthesis of few sympathomimetics. Stay tuned. Till then, thank you.